Hi everyone, this is week 2, focusing on quantitative research methods. Just a few announcements and agenda items. Make sure to get in my student email filter. The way to do that is to send to both of the emails listed here. And I just kind of made a certain filter so that you'll go into a specific folder and your email won't get lost in the mix of everything else. So especially if you want a faster response, this is the best way to make sure you get into the student email folder and I can respond to you a lot faster. Meetings. This class definitely has more individual one-on-one meeting time, so it's really needed to make sure that you are kind of guided and in line for your thesis and capstone proposal. So if you haven't already spoken with me, make sure you sign up. I look forward to hearing about your topics. And if you've already signed up, feel free to sign up again if there's room. I recommend meeting with me either every week or every other week, depending on how your thesis or capstone proposal is going. Definitely at least every other week. Okay, so for this week, just make sure you review the entirety of these slides because I do have some slides hidden. Also review the specific chapter slides. What I normally record is kind of a summary of everything or added material. And then there's also a writing lab per usual now. And you're just going to submit a very simple assignment that's developing more so your research question or your objective and specific aims. It just depends on how you're writing that. And then I also want a little bit more information on how you're defining some of the variables that you will be looking at or analyzing in your work, and also how are you going to collect the data. So I'll explain all of that when we get to the green slide, which is about the writing lab. Okay, chapter 5. Here's just some tidbits from this chapter. Manipulation and control. It's kind of a funny title. But the epitome of the chain of research really is the ability to manipulate a variable and have that turn into some type of meaningful change in a behavior. Typically, that could be an intervention, it could be a regulation even, but you're really trying to understand, if you're trying to understand what causes what, you actually have to manipulate the variables to see what the outcome is. But of course, in public health, we want to manipulate or control things in a way that creates healthy behaviors. But the variable that is manipulated, or sometimes people say predictive, or is what influences the next thing, is the independent variable. And I remember kind of confusing independent and dependent before as well. And I like to think of the independent variable as it's the influencer. It doesn't depend on anyone else. It is the variable that is going to impact another. Versus the dependent variable could be either a health behavior, it could be some type of biological proxy, and it is the one that is of interest and hopefully is the one that is affected by your independent variable. So whenever it's more, some people like to call this the outcome variable, or the dependent variable. So this is what you're hoping that it is impacted by the independent variable. So I kind of look at it as it depends on the independent variable. So that's how you kind of remember. So changing someone's healthy eating habits depends on stress, let's say, or it depends on, it's a factor that influences eating, access to fruits and vegetables, so it's not always that a variable will always be an independent variable or always be a dependent variable. It really matters how you word your research question and what you're looking at and why. So have some flexibility there. Of course, there are some things you can't change, But in general, it's really worded and thought about depending on how you word your specific aim or your research question. It's also critical to measure and control other variables that are not of interest that might influence the outcome. And we'll talk a little bit more about that when we talk about design. I might have alluded to this, but how would you categorize an intervention? Is that an independent variable or is that a dependent variable? Press pause just to think about that for a second. Okay, if you said independent variable, you're right in the sense that you developed an intervention and you're hoping that that intervention which you created impacts a specific behavior. So your intervention is an independent variable itself. And I kind of emphasize that because sometimes when we talk about different designs, I'll say, what is the independent variable? And people forget that just being a part of an intervention is a variable because you're either in the intervention group or you're not in the intervention group if it's more than two group design. So whenever there's more than two, that is a variable. So anyhow, just wanted to throw it out there that intervention itself is an independent variable because you're hoping that it impacts specific behaviors. You have to be aware of threats to internal validity. So, any type of experiment is very complex, more so than, observing data and collecting it that way through observational research. But it is a skill that you need to make sure that you really understand how to control other factors. Extraneous factors could compromise the ability to test hypotheses accurately. One classic example is how ice cream sales, so more ice cream sales, is associated with higher rates of crime, or I think the example is murder. So do ice cream sales predict murder rates? No, probably has more to do with the weather, and the weather has more to do with people being outside, more social contact, etc. But it's just one classic example, I should say, of extraneous factors where you can't really say that ice cream sales is associated or directly causes, I'll say, murder rates. There are extraneous factors that are involved in that relationship. But when you're doing an experiment, depending on the type of design you're using, it helps to control for those factors. But you still have to be really aware, depending on, again, your research design, on your specific study's internal validity and the threats to those internal validities. Here are some common ones. There's the Hawthorne effect, which that is a result of just time and attention in and of itself. So it might be that perhaps the group that's getting the fitness intervention is improving and becoming more healthy just because someone is, talking to them, paying attention to them, asking them to do things. Maybe it's not the program, maybe it's just the time and attention itself. And that's called the Hawthorne effect. And the research design that it affects most is if you have a one group design or if you have two groups, but you don't have the same amount of attention, time and attention for both groups. So a lot of times what we do when we want to make sure that it's not time and attention that is impacting an intervention group, you might say, well, the intervention group gets, 4 workshops and they get, 10 calls from a coach. So you try to replicate that same amount of time and attention. So our control group is getting a workshop, but in a totally different subject, and they're getting 10 calls from a coach, but it's about something else not related to your research question. So that is called a placebo attention group, and that really helps with the Hawthorne effect. So both groups are getting the same time and attention, and now you can really try to better understand if your intervention is working the way you designed it. And then there's diffusion. So this is when the results are due to contamination of a control group. So you can, so this happens with 2-group or multiple group designs. So you can think of it this way. If you're doing an intervention in a school, it would be really difficult to randomize one student, gets a, let's say, healthy eating class, and the next student doesn't, and you kind of intertwine. Well, the students are going to talk with each other. So the students in the intervention group might tell those in the control group, hey, this is what I'm learning and this is what I'm doing, and the control group starts to uptake those behaviors. So now you're kind of contaminating. Another example is having 2 groups too close to each other. This happened in an example with a church intervention. So we had one church, for example, that was the intervention church that received a certain program, and then you had another church that received the control, or the kind of standard, control or comparison program. Well, what happens? Some people who might go to church A, because it's so close to church B, might also attend both churches, or vice versa. So now those who are in church A and learning about, let's just stick with, let's say, fitness, they might go to church B and say, hey, this is what we're learning, and start to kind of, well, contaminate. The opposite happens too. So maybe those in church B are now going to church A and they're learning about things. So diffusion is all about contamination of the control group, such that the control group is kind of learning or doing specific behaviors similar to the intervention group. History, and so the next few are threats, especially if it has to do with one group designs. So history happens when there's an event that happens between 2 observations. And I always kind of age myself when I give this example. But a really classic example is, let's say you're doing some type of smoking public health campaign, and you collect information from your participants at one time point, and then 6 months later you do another data collection time point. Well, if in between there something happened, like a policy or a statement from someone famous, you don't know now, especially if it's a one group design, you don't know now if your intervention is what helped and made the changes, or something that happened in history. And the classic example is when Bill Clinton said, I did not inhale. And so there were a couple of either smoking interventions or groups that were doing research. And now, because this historical event happened and it received a lot of attention, now something in history, which is why it's called that, something in history happened between these observations, and now you're wondering, well, was it my intervention, or was it this thing that happened or a thing that was said that actually changed the results? So maybe after Bill Clinton said, I did not inhale, more youth knew about, smoking and decided not to. But now you have a program and now you're not sure, what was the actual influence. Anyways, that's just one example. I did this one time in a in-person class, and I had a lot of students who were like, I don't remember that event at all. And I'm like, oh, shoot, yeah, that was in the 90s. And not everybody was remembered at that time. Anyhow. Okay, maturation. So maturation is when the results are due to a participant growing older, wiser, stronger. So for example, a classic one again is working with kids. So if your research question is about, something related to weight gain, and you're measuring kids, well, you can expect that if you measure a child, 6 months to a year later, they probably have gained weight. Is it because of the intervention or the experiment? No, kids naturally gain weight as they grow. So you would just have to know that your results were affected by maturation. Sometimes people get older, wiser, or maybe if it's something related to being stronger. So this has to do with a natural progression within someone, and you mistaking it for being part of your results. Okay, testing. Testing, that type of internal validity has to do with the number of times you actually test. So if you're constantly asking a certain type of question the same way, eventually participants begin to learn perhaps what you're looking for, or they begin to learn how to answer in a certain way. So your results might not be due to what you think it is, perhaps a program or an intervention. Maybe it's just due to the fact that you're testing again and again and again. Instrumentation is also an issue. So, and this is why you want everything to be calibrated, for example. If I use a set of scales for a study that's looking at weight, and then I use the same scales a year later without calibrating, and without calibrating, they naturally either go down or go up. I might say, oh my gosh, my study worked, or it didn't work, because now everybody is, the results have changed. But instrumentation has to do with the actual instrument. And I just described an actual sort of weight scale, for example. So I always want to make sure that they're the same. But instrumentation is also, it can also be literally a scale in a, that was probably a bad first example, a scale within a survey. So let's say you have a 10 question scale on stress, from 1 to 10 is the scale, and then you decide, question 2 and 5 are worded really oddly. So when we ask this, do this scale again for our participants in this survey, let's change those items to be written in a way that's better understood. Well, now you've actually changed the scale. You've changed the instrument for which you are, testing and measuring people. So is the change really due to, what you intended, or maybe by changing the questions, it was more understandable? So that has to do with instrumentation. So whatever you're using to measure, it should be the same. And again, that kind of has more of a threat if there's a one group design. Sometimes things change naturally, and that's why having more than one group is beneficial. The next one is statistical regression, or probably what I've heard more is regression to the mean. And this example is, let's say you are in the beginning of the school year and you take a stress survey, and in the beginning everyone's excited and ready to go, and everyone seems kind of less stressed. But then you take it again 3 weeks later, and there seems to be a better curve of low to medium to high stress. Well, this is an example maybe of regression to the mean, where at the time that you took the first survey, you were getting somewhat extreme scores. Maybe there was a lot less stress at that time, or a lot more stress, who knows. But when you measure again, the scores seem to go back to their normal or average levels. So sometimes this happens depending on timing, and that's called regression to the mean, or statistical regression. So when you first get some type of extreme score, and then you test again, and you kind of get more of the true kind of responses, it'll go back to average. So again, that's regression to the mean, or statistical regression. And then you have differential selection. So let's say you do have two groups or multiple group design. Differences could exist between participants before the treatment occurs. So let's say that you selected, you asked certain people to be a part of the intervention group, and if they weren't interested, let's use fitness again. If they weren't interested in fitness, then maybe they could be a part of the control group. Well, now you've really made the two groups of participants very different. Some are motivated and willing to volunteer. Some were just willing to not be a part of the fitness, but be a part of the control group. They're very different people. They weren't randomly assigned. And so that already creates differences. So let's say you were interested in motivation to exercise. Well, the way that you recruited, your intervention group is obviously going to be way more motivated. So there's already differential selection there. The same is true for differential loss. Let's say that you had those same two groups, one highly motivated group around fitness and one that wasn't so motivated. They were willing to be a part of the control group, let's say, but there was more dropout in the control group. Well, there's differential attrition because the participants were already different. So there's a different reason that, and it could be around motivation, why more people in the control group dropped out versus the intervention group. So again, differential selection is you're kind of selecting people into groups that already make them different. And differential attrition could be just the differential loss of participants from each group. Not only could it be because of certain characteristics, it could be something a little bit more programmatic. Maybe the control group got less of something, maybe their meeting times were inconvenient. So there was something different about the group that made them drop out of the study. So that's something, another common thread. And I had these numbers here when I was doing the in-person class and kind of putting people into groups and coming up with examples. But hopefully the examples I outlined could help you understand the material a little bit more. But always definitely continue to read the chapter slides and also the textbook to give you more context and perhaps some other examples. Okay, here's some chapter 5 extras. This just kind of, for me, sums up chapter 5. This comes from a different PowerPoint course that's very similar, but just kind of going over some definitions. So when we're talking about the experimental group, this is the group of individuals who actually receive the intervention or the thing that you're manipulating, right? As in our first slide. So this is the experimental group, those who you're hoping to see that by receiving this intervention, it impacts them in such and such way. The control group, as much as possible, should be similar, but the individuals in this group do not receive the intervention. To be a part of a control group, individuals should be randomly assigned. We'll talk about sampling and random assignment a little bit later, but everyone should have equal opportunity to either be in the experimental group or the control group. It's completely random. And the premise for having a control group is, the right to status quo, and, everyone is informed of the purpose, there's a right to new services, and you're not subjected to harmful programs. So that's a control group. But there are times when you cannot randomly assign people to experimental or control group, and then a non-equivalent group can be formed. So this could be kind of similar to what I was describing earlier. Maybe you were using flyers and people were aware that they could be in the intervention group, but you still needed a group to be a part of the control group. Sometimes this happens when you have multiple sites. Let's say you have 2 clinics that are willing to be in your study, but one, maybe not 2, but let's say you have multiple, but certain clinics are eager to be a part of the intervention, and instead of randomly assigning, you say, well, since we're just starting off in this study or it's something a little bit more exploratory, let's assign these 4 clinics to be a part of the intervention group or the experimental group because they're motivated and we know we can get the work done, and then the other 4 clinics can be a part of the comparison group. Well, you're already setting them up to be a little bit different, and sometimes it happens for budget reasons. Sometimes you ethically cannot randomly assign people, especially if you're looking at disease or other health outcomes that already exist. So just be aware that the experimental group is the group of people who receive the intervention. When we say control group, it's usually implied that there was some random assignment, versus a comparison group where for some reason or another individuals were not randomly assigned to the experimental or a control group. So again, kind of a non-equivalent group is formed. So that's just a little bit of terminology around groups. Okay, now we have some evaluation designs for thinking about how do you design a research study. Experimental design. Again, this offers the greatest control over extraneous variables, confounding variables, and it involves random assignment. Most classic experimental design is a randomized control trial, where you randomize your participants to either the experimental or a control group. It does produce the most interpretable and defensible evidence of effectiveness. So really, if you're looking for a cause and effect, experimental design or a randomized control trial design, which is experimental, is the only way. It's kind of the gold standard for talking about cause and effect. In some cases too, you can kind of hint at cause and effect with quasi designs, but not as much as the gold standard of the true experimental design. So quasi-experimental, here we have comparison groups. So the results are interpretable and they're more supportive of the evidence that a program works. But because the groups are different and they're non-equivalent, you cannot control for all factors, or you did not control for all factors, simply because there was no random assignment to the different groups. So that's why they're called comparison groups, because their comparisons are made, and despite it not being an experimental versus control group situation. And sometimes you just don't have another group to have as a control group or to compare to. So this would be a non-experimental design. And with this type of a design, you have very little control over those internal validity issues that or threats that we just talked about. You don't know if a group is changing because they're getting more attention. You don't know if your instrument is changing in the way that you're measuring. You don't know if something historical happened, or if it did happen, you're not sure if that was the cause of your result. So non-experimental studies, again, you have little control over some of those extraneous variables that might affect your results. Okay, so now here is a slide on the various types of evaluation designs. I'm going to try to use the pen here, but I don't have a real pen. I'm just going to use my mouse. But the way I like to describe this slide is that I don't want you to memorize the designs and memorize the X's and O's. But if you know the basic formula, then you should be able to read what type of design it is, reading from left to right. So let's actually start from the bottom, non-experimental design. If we're looking at O's are the measurement point or observation. So O1 is observation 1 and O2 is observation 2. X is the intervention. And so just without looking at the words, just looking at this from left to right where I've underlined and circled, it's a pre-test, something that happened before, and a post-test because I can see it happened before and after the intervention. And then the one below it is a time series design where you just have one group again, but multiple observation time points. So that's non-experimental, just reading left to right, pre-test, post-test, or time series design. Well, now we're going to add a second group, and this adds a second line. And remember, the second group doesn't receive the intervention, so there's no X. But let's look at this top line. We have, again, a first observation, oops, right here, and a second observation. So knowing that there's two groups, and maybe I should have started with the R's, knowing that there's no random assignment, I can already see that this is a two-group design and it's quasi-experimental, pre-test, post-test. And again, on the bottom, it's a time series design because there are multiple observation points. But what I'm alluding to is now, if you go to experimental design and you have an R in front of it, now you know that the groups were randomized. So here you have a time series design, where you have the first observation, the second observation, third, and the experimental group gets the intervention. And then everybody again gets the fourth measurement, fifth, and sixth. So measurement or observation. And again, reading from left to right, I can already tell it's experimental design because there are two R's. And here's an example again of an experimental pre-test, post-test design. And the second one is, again, I see that there are R's, so I would say experimental, but look, there's nothing here. There's only a post-test, so I would say experimental, post-test only design. And so again, the intervention is only for the experimental group, not the control, and not for the comparison groups. So if I were to say, draw me quasi-experimental post-test only design, how would you draw that? And if you want to pause and give it a shot, that would be good. But if not, I'll give you the answer right now. So if you were doing, again, quasi-experimental post-test design, post-test only design, it would essentially be, we know there's two groups, so we know it's post-test only. So you haven't, sorry, I don't have a real pen, just a clicker. So you have two observations here. One group receives the intervention. There's no R because there was no random assignment. So within this box, if I'm reading left to right, I'm seeing that it's a quasi, because there's two groups, a quasi post-test only design. So again, that's kind of why I mentioned I don't really want you to memorize, but knowing if there's an R, it's already experimental. And then seeing where the O's are, you can decide, is it time series because there's multiple? Is it a pre-test, post-test because there's something, an observation happening before it, an observation or measurement happening after? Or is it a post-test only where there's only a measurement after the intervention began? And so again, if I throw out some other type of design, you should be able to write it out just thinking about those basic elements. Hint, it's probably on a quiz. Actually, we have exams in this class, so make sure you understand because you will get these types of questions on the exam. Okay, so here's a little exercise that I usually do in class, but I'll kind of talk it through. So feel free to pause if you want to try to figure it out before I give you the answer, and so you can think about it, which is what I recommend because you will remember more whether you get the answer right or you get it wrong. It helps to kind of work through these yourself, but I'm just going to go ahead and go through the examples and through this exercise. But again, feel free to pause before I start giving the answers. So for this, for these next 4 slides, we're going to look at either a scenario or a research question and try to decide, what is the independent variable? What is the dependent variable? And can we, get a hint, at least a little bit, or maybe completely, of what is the research design or the evaluation design? So here, this one says, do employees of XYZ clinic who participated in the workplace health program meet guidelines for exercise, 150 minutes per week, compared to employees who were randomized to the control group? So think about, what is the independent variable? What is the dependent variable? And what do you think the design is, at least in part? Okay, so here is how I look at it. That very last part, control group. Now I'm already thinking, okay, I know that the design is experimental because there is an intervention group and there is a control group. Looking further into it, there's no information on timing, so all you can really say about the design is that this is an experimental, a true experimental design. But when I'm thinking about the independent variable, well, again, we know that some type of program or intervention happened, so the independent variable, or the thing that was created or manipulated, was a workplace health program. So this is the independent variable. And the program is trying to impact exercise. So exercise is the variable, which is the dependent variable. Here it's nicely defined as 150 minutes per week. Most of the times we're going by CDC guidelines. Another hint to what this design was, again, is the word randomized. So we know that people were randomized to the control group. So again, here the answer is that the independent variable is an intervention. It's the workplace health program. The dependent variable is exercise, and here it's defined as 150 minutes per week. Actually, a better definition is 150 moderate to vigorous minutes per week of exercise, compared to employees who were randomized. So here we can, again, the IV, the DV, and the design. Here I'll just put D right here. Kind of gave me a hint based on the words randomized and control group. And the reason I'm going through some of these exercises is this is a potential research question. Not too many people, at least for your own thesis or capstone, are going to have research questions related to an intervention, but at least you can kind of start to see and have an idea of how specific research questions could be, so that when you think about your own research question, you can do something similar or think about something similar. If this wasn't an intervention type question, and you kind of wanted to model off of it, you could say something like, what is the relationship between stress and exercise, between those, or among, employees at XYZ clinic. I don't know. But at least you can see how detailed the research question and how specific it is. So that's the first example. Here's the second example. Do elementary students in the nutrition program meet guidelines for fruits and vegetables compared to students who are in the comparison group? So again, I'm already going to go to this word comparison group, and now that I can see the design is quasi-experimental. And it's kind of confirmed by understanding that there is a group of students who received a nutrition program versus students who did not, and they were a part of the comparison group. Well, it doesn't necessarily they received no intervention, but we're comparing between those who were in the nutrition program and those who were in the comparison group. So what is the independent variable? Again, the independent variable is the fact that there is an intervention involved, and the intervention is trying to impact or influence fruit and vegetable consumption or guidelines. So this would be the dependent variable. So again, the design is a quasi-experimental, and again, there's no time period here. It doesn't say before and after or after a program, so you're not sure, as far as the timing goes, but you can tell just based on the words that it's a quasi-experimental design. There's an intervention involved, so that's the independent variable, and it's trying to impact the dependent variable or the outcome of interest, which is fruits and vegetables. Okay, so here's another one. You were asked to evaluate a diabetes program among older adults in an assisted living facilities, where one facility received the program and the other was assigned to not receive the program. And the question is, were participants in the diabetes program more knowledgeable in diabetes care than those who did not participate? Okay, and we're going to assume here that were participants in the diabetes program more knowledgeable compared to those who did not participate, and we're going to assume that that was the facility that did not receive the program. So that could have been worded a little bit better. But I can already tell that this is a quasi-experimental design because of these words, where one facility received the program and the other was assigned, not randomly assigned, but it was assigned to not receive the program. So this kind of speaks to the design. One, that there's two groups, but one was sort of given the program and the other one wasn't. And now that I'm thinking and looking at the question, you know, we're participants in the diabetes program. So again, this is our independent variable. It's an actual intervention. More knowledgeable in diabetes care. So this is what was hoping to be impacted or changed. So this is the dependent variable. So again, you kind of have to read these very carefully, but there are certainly keywords that can lead you to understanding, you know, what the design is, what is the independent variable or the dependent variable. Okay, here's the last example. One church implemented a breast cancer screening program, and you were asked to evaluate it after it had already started. And the question is, did church participants increase their intention to get screened for breast cancer? Well, thinking about design, I can already see here one church, and I didn't see a reference to another, received some type of program, so they did get an intervention. One church implemented a breast cancer screening program. The next words were, and you were asked to evaluate it after it had already started, meaning you didn't have an opportunity to do any type of baseline measurement or observation. So I'm going to put an observation here. So this is basically the design. So here, I'm just going to put D for design, that I can kind of tell, also based on the fact that it had already started. This is a non-experimental, post-test only design. So again, there's no other comparison group, which means it's non-experimental. There's no observation beforehand, so it is a non-experimental, post-test only design. And the question is, did church participants increase their intention to get screened for breast cancer? Okay, now this is a little bit tricky because you do have an intervention here. However, there's not another group. So the question would be, is the intervention a variable? And I'm actually going to talk about that a little bit later too. But basically, there's no other group. Everybody is a part of this screening. So this should actually say something like, did church participants, let's say something like, who will say attended, oh gosh, I can't write with the mouse, who attended, let's say, who attended more than 10 times, that would be probably a better way of putting it. Did church participants who attended more than 10 times increase their intention to get screened for breast cancer? And the comparison now is among those who did not attend this program more than 10 times. Because you can't compare to those who did or did not receive an intervention, because everybody was a part of it, versus being able to understand, you know, what part of the intervention is different that you could examine. So if I were looking at this, I would actually say the independent variable is whether or not the participants attended the program more than 10 times. And the dependent variable is actually intention to get screened for breast cancer. So again, the design, it was one church and the program had already started. So really your only option is a post-test only. And the independent variable is, it's really hard to say, did the intervention impact, especially if it's post-test only. You're doing one measurement. So you'd have to kind of create some variability. So is it those who attended more that were more likely to get screened or had greater intention versus those who didn't? Or what else was it about participants that is variable that you can examine whether it impacted intention to get screened for breast cancer? So, so looking at this, when you get an example, you won't have to make up stuff like I just did to make sure that it reads well. But everything will be laid out so that you can identify an independent variable, a dependent variable, and based on keywords, identify the type of design. And again, know your X's and O's, and whether there's an R or two groups or not. And you should be able to read the design going from left to right. And so you'll definitely need that skill for the exam. Okay, a couple of chapter 6 extras. Okay, so this chapter is based on sampling, and I have other slides that kind of more concisely kind of summarize chapter 6 on sampling. A little bit of terminology. Census is all participants or all people. So for example, the US Census. A sample is just some of the participants. A sampling unit. This is important to kind of understand the difference. It is the element or a set of elements that are considered a part of the sample. Now this could be an individual. It could be excuse me. I won't redo the voiceover, but excuse me. It could be an individual. It could be an organization or some type of other setting, a school, a clinic, or it could be a geographical area. So for example, I worked on a study called Veinaction, and the sampling unit was the church. So, and the sampling unit is who is the sample? And who are you randomizing, I should say? Who's the unit? So we didn't randomize individuals. We randomized churches. So churches would be the sampling unit, if that makes sense. And there's some studies that kind of randomly assign different types of program by geographical area. So the geographical area would be the sampling unit, not the individuals themselves. But if you're trying to understand individual behavior change, and there's no overarching group, or shoot, I'm forgetting the word. There's no overarching structure or the way that they're randomized, then you are looking only at the individual. Sampling is a process by which a part is taken as representative of the whole. So if you have a whole population, let's say, you're taking a sampling that you hope represents the population. Now the universe is unspecified by time or place, whereas a population is specified by time and place or location. So if you're interviewing participants today, at CSUSM San Marcos, that would be a very specific time in history or time by year, and place or location. And then survey population are those who are accessible. Also called your sampling frame. So if, for example, like in the past, now that we have cell phones, it's completely different. But let's say in the past you wanted to get a good sample of participants within a specific geographical location, you could randomize home telephone numbers and start to call everyone. And you're hoping that those that you call and those numbers that you have access to is a good representation of your population. But that is just your sampling frame, because you would not be able to call people whose numbers either you don't have or are not listed, or they don't have a number. So again, some people won't actually have a number that you can call. So your sampling frame is not the entire population, but it's your survey population or your sampling frame. Here's another way of looking at it. The sample are those part of your study. And then you have your survey population, which is basically your frame, your sampling frame. Where are you getting the people? And you're hoping that is similar to your population. And going further, you hope your population is somewhat similar or is within the universe. And just here's another way of looking at it. You have your population, and from the population, you have a sampling frame. So again, if we're kind of using that same example, let's say you're interested in surveying people within a specific location, all those people in that location, that's your population. But your sampling frame is, well, how are you going to contact everybody in that population? Let's say it was back in the time where we had more landlines. You would have home telephone numbers. Well, again, not everyone has a telephone number, but many people did. So that would be your sampling frame. It doesn't include the whole population, but a good amount. And you're hoping that the amount of people that it does include, is similar to the population. But ultimately, you have your specific sample of people that are part of your study, and ultimately, in some way, you hope that the sample has similar characteristics to the actual population. So sampling procedures. You can have sampling procedures that are either probability sampling or non-probability. So with probability sampling, every single person or element, again, it could be an individual or it can be some type of unit or a setting, let's say schools. So everybody that you're going to randomize, everybody that you are going to sample has an equal chance or probability of being selected. So there's no differential way of saying I want this type of person or that type of person. Everybody in the survey population has the same equal chance of being selected. Non-probability sampling is that there is not an equal chance. So there's some type of convenience, or people are volunteering, or there's some issue around availability, being easily contacted, or maybe because they have a certain characteristic that you're looking for. So again, not everybody in the survey population has an equal chance of being a part of your study. So probability sampling, everyone has an equal chance. Non-probability, they do not have an equal chance. Okay, so probability sampling procedures, again, where everyone has an equal chance. You can get to that in a few ways. It could be just a basic, simple random sample. You can do that with random numbers, just 1, 2, 1, 2, 1, 2. Everyone has some type of equal chance of being selected. You could do fishbowl out of the hat. So it's not as precise, but it's pretty similar to simple random sample, where you have everyone or every unit in a fishbowl and you select out of a hat. Systematic sampling kind of uses lists. And there's a specific constant. So it might be every fifth person that is in a classroom, for example, I do this sometimes, will be selected. This is still a probability because everyone kind of has an equal chance in that as long as it wasn't, you weren't seated in a certain way because of some other characteristic and where you're sitting is kind of random, then picking every fifth person is also kind of random from the beginning. So cluster or area, that was the word I was looking for. So like either clusters or groups. Now again, these are not individuals, but you might do a simple random sample of clusters or areas or groups. So again, in my church example, we didn't randomly select individuals or randomize individuals. We had a random sample of churches, not individuals. So another way to look at that is our sampling frame could have been a whole list of churches, and we randomly sampled the different churches. So every church on our list had an equal chance of being selected, but we only selected 8 churches to invite to be a part of the study, for example. So again, that's random sampling. I hope I didn't confuse you when I first said randomization, because again, that's different. That's when you're randomizing someone to either an intervention group or a control group or comparison. You're randomizing them into a group. Right now, what we're talking about is random sampling. You're just sampling people randomly to be a part of the study. If there are more than 2 groups, then you can randomize into different groups. So I'm sorry if I confused you in the beginning with my verbiage, but right now we're talking about sampling, and that's having a sample of people to be a part of your study. Another way of sampling, probability-wise, you can stratify. So there are 2 types of ways that you can stratify. One is called proportional stratification, and the second one is called non-proportional. So proportional divides subgroups or some type of strata in a way that is proportional to how they're divided in the regular population or how they're represented. Non-proportional is the opposite. It's not proportional to the strata or to the subgroups within a population. And the next slide will help explain a little more. Okay, so let's say we're in a scenario where we want to select 100 students from a school population of 1,000. Well, proportional sampling would be, let's say in both scenarios, we have 400 freshmen, 300 sophomores, 200 juniors, and 100 seniors at the school. To be proportional to the population, the first way we would do it is to select in our sample 40 participants who are freshmen, 30 who are sophomores, 20 who are juniors, and 10 who are seniors. And this is proportional to the actual population of 1,000 students. Well, let's say we have something about our research question really wants us to make sure we have enough, juniors and seniors, and we really just want equal. Well, now we're just going to split it 4 ways. We want our sample to be 25% freshman, 25% sophomore, 25% junior, and 25% senior. Well, this is not proportional to the way the demographics are in the school population. So this is really a tricky question, and hint, it might be on the exam, because when you're looking at the sample, you might have an inclination to say, oh, this is proportional sampling because everything's 25. But remember, it's always, is it or is it not proportional to the population? So what is the proportion of the groups or strata within the population, and are you replicating that within your sample? So make sure that you're always comparing it to the population and not just looking at, oh, everything's 25%, so that's proportional. It's actually non-proportional because it doesn't represent the same proportion as the population. If the population was also 25, 25, 25, 25, then it would be proportional. But hopefully you just stick with that question. Is the sample proportion similar to that of the population? And that tells you whether if it is proportional or not. Okay. Non-probability samples. So this is when, for some reason, you cannot have a probability sample. If it's either you can't do it or maybe it's just not needed. Sometimes it's just that resources are limited. Participants can be included because it's out of convenience, or again because they have a certain characteristic. There are certain limitations, so it's really hard to generalize to the survey population because again, you're not sure if they're actually representative. And bias can occur since those who were included in the sample may differ from those who were not. So again, it's limiting because it makes it hard to kind of speak to how your sample is similar to the survey population. Here are a few examples of non-probability sample. Convenience. This is just includes some type of accessibility. A really basic example would be you want to do a survey on what people purchase in a store. Let's say it's a convenience store and you're literally outside the door and saying, whoever passes by, it's noontime, whoever passes by, I'm just going to ask them if they can fill out this survey. That is a true example of a convenience sample. Volunteer, those include those who are motivated. I kind of alluded to this earlier, talking about different designs and how it plays out when you're comparing groups. But let's say you have a flyer out and you're asking for those who want to be a part of a specific program. Well, now there's some type of volunteer characteristic in there. So if your survey, if your population was, let's say, CSUSM students, but you're asking for students to volunteer to do something specific, those who actually decide to self-select are not going to be representative of the whole entire campus, for example. Non-probability can also be homogeneous, so kind of similar. It includes those selected because of a unique trait. There's snowball design, and this is kind of a referral. So I use this in some qualitative work. So if I do surveys with specific participants, I might say, can you name somebody else who might be interested in this survey? And that kind of creates a snowball effect. So now you have names and you go after them and say, hey, someone so-and-so referred you. Would you be willing to participate? And it just snowballs, and you ask the next person and the next, and it kind of snowballs into the number of participants you want. But again, it kind of depends on who's referring, what are their characteristics, and again, so it's not, it's a non-probability sampling. It's not going to be truly representative of the population. And then you have quotas. So this includes those chosen in some type of, it's similar to stratified, but not quite, in approximate proportion to the population traits they represent. Okay, chapter 7, just a little bit here, but I also have intermittent, again, slides from another source, which is from Pearson. So it's just another way to summarize some of the methods that are described in the Salazar book. Okay, measurement is kind of an art and a science at the same time. It's everywhere because we're always thinking about how do we understand things, how do we measure it, can you define that? I mean, that's measurement. It's central to really understanding health promotion research, and each way that you measure is recorded in some type of metric. So some examples could be Fahrenheit and Celsius for temperature, SAT GRE scores for test scores, or a validated IQ test for intelligence. So there's some type of metric in the way that you are measuring. It's important, to understand measurement in program planning and evaluation, and just as a public health professional or health education specialist, you need to be comfortable and competent in measurement. It might be because you are trying to find evidence and create a rationale. So you're looking at other interventions and you want to know, did they measure in the way that you would define something, or did they measure something appropriately? So you would have to have the knowledge to be able to assess that. If you're conducting a needs assessment, you have to come up with the appropriate measurements there. And also if you're planning an evaluation, or if you're interpreting program results, you should understand measurement, and also just having general evidence for a funding agency, so which basically is all of the above. So overall, in general, it's good to have be comfortable and have some competence when it comes to measurement, how you measure, how do you define it, etc. So it's important in our public health world, and especially in research. Now there are different types of variables. There's mediating, moderating. The difference between those two is, let's say you want to understand how stress relates to eating habits and how eating habits relates to weight status or obesity. So you might say that eating patterns is, probably want to be more specific, maybe like caloric intake, etc. But let's say eating patterns is the mediating variable between stress and weight status. So it's something in the middle that has a relationship with both. So stress is related to eating status, and eating status is related to eating patterns is related to weight status or obesity, for example. So again, eating habits or behaviors, that's mediating the relationship between stress and weight. Now, moderating would be, let's say you're interested in stress and weight, but you're interested in how that differs between men and women. Well, the category or the variable of gender is not mediating. It's not stress, then leads to gender, then leads, that's mediating. No, it's moderating, it's categorical. So the relationship between stress and weight is one for women, and the relationship for stress and weight is another thing for men. Now again, you're just those are moderating variables, so you're trying to understand, is there a difference or is there not a difference? But you're looking at it in such a way where you're looking at the relationship for the subgroup of the categorical variable that you just named. So mediating, again, there's something kind of mediating in the middle. Stress leads to eating patterns leads to weight, versus moderating. You're interested in stress and weight, but how does that differ between men and women? So gender would be a moderating variable. So that's the difference between mediating and moderating. You can have a whole class on mediating and moderating, but hopefully that was a good brief example. And then other types of variables, self-report, variables that you observed through direct observation. It could be through records review, such as medical records, or maybe you collected samples, blood, urine, and could assess things biologically. So those are different types of variables. Okay, so I alluded to this a little bit earlier, but one of the most fundamental aspects of measurement is, well, the metrics. But a variable, what is a variable? Sometimes we kind of take that for granted and say, well, we know what a variable is. It's just something that you're looking at, right? Well, not quite. It's a single measure that, by definition, can take on more than one value. And the reason I emphasize this is because a lot of times I'll see in research questions, it'll say, I'm interested in stress and weight among, let's say, Pacific Islanders. And then I'll ask student, okay, so what are your, independent variable, dependent variable? And they'll say, one of my dependent variables is the category of being a Pacific Islander. Well, it's not a variable if everybody in your study is Pacific Islander, for example. So again, it's that difference between, why is it not available? Because everybody has it. There's only one. And the difference, so the word variable, just think about it literally, it varies. So if something in your study does not vary, then it just is. That's just a characteristic or an inclusion criteria, for example, of your study. But if there's no variation, if it doesn't vary, then it's not one of your variables. And as simple as that might seem, a lot of people name, things, characteristics on there as their research question as an independent or dependent variable. So just think about it that way. A variable is something that you can measure that can take on more than one value. So intervention, that is a variable if there's more than one option, which is you are in the intervention or you're not in the intervention. That is a variable in and of itself. If everybody received the same intervention, then there's only one. Everyone received the same thing, and it's not a variable. There are 4 different types. So there's nominal, ordinal, interval, and ratio. So again, as simple as that might seem, just remember that if it's not something that varies in your study, it is not one of your variables. So really think about, what is my independent variable? What is my dependent variable? And make sure you're not naming something that is just a characteristic or some type of inclusion criteria as being a part of your study. Okay, so nominal, this is categories, so typically just called categorical variables. There's no order, they're mutually exclusive. It could be Democrat, Republican, Independent, red, blue, yellow, green. There's no order to them. It's numbered funny. Number 1 of 1, just kidding. The next number 1 is ordinal. This is also in categories, but it is mutually exclusive and exhaustive. And it's also rank ordered. However, the difference between this and the other types is that you cannot measure the distance between the categories. There's no defined measurement in between. It's simply rank ordered. Level of satisfaction or agreement is a classic example. So you can highly disagree, agree, or highly agree. Now there is some order to them, but what is the difference between highly disagree and disagree? Is that the same distance between agree and highly agree? Is disagree to highly agree, twice that of agreed? No, there's no measurement in between this. It's simply just rank ordered. There's some order to them. Interval. So this is now we're getting into numeric data. So now we're not into categories. It's mutually exclusive and exhaustive, rank ordered, but it can measure the distance between categories. And if you notice, the description for interval and ratio are the same with the exception of the last part, which says for interval data, there is no absolute zero. And the meaning of absolute zero is that 0 means 0, or 0 means that there's nothing or that something does not exist. So the classic example is temperature. Is 0 degrees, does that mean that there's no temperature? No. Many people on the East Coast would disagree with you. Or maybe you are on the East Coast. No, there is still something there. 0 degrees still means something. It doesn't mean an absence. So in interval data like temperature, there is no absolute 0 versus ratio data, which is mostly of what you'll work with if you are working with different types of data other than the different types of categorical data. So again, it's in categories, it's mutually exclusive and exhaustive, rank ordered, you can measure the distance, but there is an absolute 0. So in this case, 0 means something. 0 means none, doesn't exist. So if we think about, for example, minutes of exercise, 0 means you didn't exercise, there's none, it actually just didn't happen. If we think about weight, 0 means there's no weight, again, none. So it is kind of tricky, but think about it this way. An absolute 0 means there's absolutely nothing. And that 0 literally means it doesn't exist, or there's 0 or nothing. Versus no absolute 0 means that 0 still means something. So those are the 4 different types and levels of measurement. Okay, measuring constructs. So in health promotion, we have a lot of research questions that are kind of centered on intangibles. So it's not something you can actually grab or see, but it's a construct like self-esteem, depression, self-efficacy, etc. So the first step is to create a formalized definition. So what is the definition of depression? What is the definition of a specific attitude? And the next step is to create, with a caveat, questions or items that measure this construct. Questions or items should be designed to be distinct indicators of this construct, such that each question or item is related. The final step is to actually test, the collected items as an entire scale. But I have this caveat of don't reinvent the wheel. We know, for example, there are already developed scales for self-esteem, depression, self-efficacy, different types of attitudes, perceptions, and beliefs. So you only really need to create questions or create a scale to measure a construct if it doesn't exist. And more likely than not, there is already something that exists that is either similar that you can adapt, or you can use in its entirety, which is preferred. But again, don't reinvent the wheel if you don't have to. Now, just to kind of show the difference between a scale and an index. So I was talking about scales. Scales is a measure composed of theoretically correlated items. So everything correlates with each other. Multiple effect indicators that relate to how constructs manifest. So how you're measuring stress, for example, you have a whole bunch of items that are related to each other. An example that we'll see in a second is the self-esteem scale. An index is simply a list of items. It can be items themselves, but they might not necessarily be correlated with each other. And we'll see that in the next example. So again, a scale, you're really trying to get at, for example, self-esteem. So you have all these items that are related, and you can create some type of a score based on that, but it's a scale because they're all related, versus an index, which is essentially kind of a checklist that gives you more of a checklist type scoring. So here's an example of a scale. You have questions related to self-esteem. I was bothered by things that usually don't bother me. Number 2, I did not feel like eating. My appetite was poor. Actually, this seems more like stress. Oh, sorry, it is a depression scale. So it's not the self-esteem scale. It's a depression scale, which is what it seems like. So everything here is related. I felt depressed. Number 6. Number 7, I felt that everything I did was an effort. Number 8, I felt hopeful about the future. All of these things are related to a level of depression. So someone can either answer rarely or none of the time, or I felt this way most of the time. However, when we look at a life events checklist, this is what is considered an index. So it either happened, you witnessed it or learned about it, or just doesn't apply or not sure. But these things are not necessarily related. So were you involved in a natural disaster, a fire or explosion, transportation accident, a serious accident at work, home, or recreational activity? So these are things that you check off as an indicator or kind of as an index. But a fire and explosion is not related to whether you had a transportation accident. So again, that's the difference between a scale and an index. An index is more like a checklist of things versus a scale. They're all interrelated, trying to better understand and measure a construct. Characteristics of data. When you're trying to understand reliability, validity, and fairness, those are the psychometric qualities of a scale, for example, or the data that you have. Reliability is consistency. So if you are measuring something, is it going to be the same each and every time? So it's the degree for which a measure is free from errors. But the attained score is the true score plus some type of error. Validity is whether something measures what it intends to measure. So is it actually correctly measuring the concept or construct that you're trying to measure? So again, if we look at these target practice points, the first one, you see a whole bunch of clusters off to the side. Well, it's not hitting the target, so it's not valid, but it sure is reliable. The next one does not seem reliable because everything's all over the place and you're not quite hitting the target. However, statistically, if you were to take the average of all these, it might be considered valid. The next one is not reliable and not valid. And the next one is considered both. It's both reliable and it is valid. So again, the first one is reliable, not valid. The other one is valid if you're taking the average, but not reliable. The second one is neither reliable or valid, and the last one is both. It's both reliable, it's always reliably hitting the same spot, and it's hitting the correct spot, and it's valid. So that's reliability versus validity. So there are different ways that you can sort of determine or test for reliability. Here are different types. There's internal consistency. So it kind of checks to see if the items on a scale or some type of instrument are measuring the same construct or the same research domain. So are they basically correlated with each other? Test, retest, so there's some type of stability here, is if you use the same instrument to measure the same group or the same conditions at two different time points, and if you're expecting the test or the result to be the same, that is test, retest reliability. So if you're measuring at one time point and measuring at a second, and again, there was nothing in between or no intervention, you're not trying to change anything, you just want to see under similar conditions or in a similar group, do you get the same result? That's test, retest reliability. Now, if you wanted to measure something, there's two types when it comes to rater reliability. There's me rating something twice. If there's reliability there, did I get the same result? That, because there's only one person, that's intra-rater reliability. So kind of like intrapersonal, one person. Inter, again, kind of like international or just more than one. Inter-rater reliability, two or more. Let's say we're trying to count how many people are exercising in a park. If I give, I say there's 5 people and the person next to me also says there's 5 people, then we have good inter-rater reliability. If I say 5 and they say 10, well, there must be something wrong between us. But also you want to kind of look at it from a data point of view. If we're doing something and the two raters are not consistent in their observation, then there's something wrong with rater reliability. So again, when it has to do with raters themselves, one person is intra-rater reliability. So if you're doing it a couple times, it's that one person's ability to be to rate reliable, and then, or if it's 2 or more people, it's inter-rater reliability. And then you have parallel forms reliability. So that focuses on whether different forms of the same measurement will produce similar results. So again, you're measuring the same subjects, but maybe you have someone taking different forms, trying to understand depression. So maybe there's the classic depression scale, and then maybe there is a depression observation. I'm just making this up. But again, you're trying to understand the same construct, but you're doing it in different forms. One is a survey, one is a scale within a survey perhaps, and one is a type of observation that is still also trying to measure depression. It could also be let's say like using technology. Maybe you have a weight scale that has one reading, it says 150 pounds. And then you have some new technology that can just zoom in on a person and say that person weighs 150 pounds. Well, you'd have good, parallel forms reliability. They're giving you the same result. If you're trying to measure the same thing and it's not coming out the same, then you have a reliability issue. So again, that's called parallel forms. You're trying to measure the same construct, but you might be doing it with different forms or different instruments. Okay, so a little bit more on validity. Again, are you actually measuring what you intend to measure? For a measure to be valid, it must also be reliable, but a reliable measure doesn't always have to be valid, just like we saw with the targets. There are different types of validity for you to be aware of, and here are the four main ones. The first one is face validity. So it's almost like on face value, does it appear to measure what it's supposed to measure? If I said I was interested in understanding stress, and I said, well, one of my questions for participants is, what is your favorite ice cream? I might say, you know what, at face value, I'm not sure that really measures stress. Some might say it does. No, I was kidding. That's probably how much ice cream you eat if you're stressed out. But no, on face value, you would say, well, that doesn't seem to be measuring stress. But if I asked, what is your current mood? That might be a little bit more related to whether you're stressed out or not. But your favorite ice cream, on face value, doesn't seem to be related to that particular measure. Content are the items a representative sample of the type of construct you're trying to measure or the domain being addressed. A lot of times this is typically created by an expert panel. So you have people who are experts in stress and they say, hey, if you're going to create a scale in stress, make sure to include what's a good kind of like stress question? Did they feel always in control? Make sure you have that in stress. What is their reaction in the face of time or something like that? So an expert panel on stress might start to delineate, you need to include all of these different types of questions and items and content in order to really address and correctly measure stress. So again, that's content validity. Does it include all the items that are needed to do a good measurement? Now, criterion and construct are a little tricky, but criterion-related validity has to do with whether the scores are correlated with some other measure of an individual's behavior. And it can either be predictive, so that maybe I'm stressed out, but I'm using stress a lot. That for students, stress predicts exam scores, let's say, so that's predictive validity, or concurrent validity. Let's say you have a new and established scale on stress, that would be concurrent validity, so criterion related. Now, construct, so again, it's kind of separate. It has to do more with the individual's behavior or performance. So that stress predicts a lot of things. And so you can kind of guess what about the behavior or performance on something can be related to stress. Construct has to do more with the degree to which a measure correlates with other measures that it's theoretically expected to correlate with. So we would expect, for example, stress to correlate with mood, to perhaps correlate with depression, to correlate with feelings. These are other constructs that we expect it to correlate with. Convergent validity is what it should correlate with, but you can also look at things that it does not correlate with, and that's called discriminant validity. And that's how you make sure that, that's another way to make sure you're measuring the right thing by knowing that stress probably shouldn't correlate with your favorite ice cream. And so if you run the statistics like, nope, it doesn't correlate with ice cream, then you have some good discriminant validity. Of course, you want to look at something else besides ice cream, but that's just one example. Convergent validity, you say, okay, I want to make sure that I know stress is related with, is correlated with depression scores. So let's make sure that they are correlated, that we're, kind of getting at the same, not the same construct, but that they should be theoretically correlated with each other. And so that's convergent validity. So those are 4 different types of validity to know that what you're measuring is what you intend to measure. Again, that's validity. And then fairness. In any type of measurement that you do, you always want to make sure that it is appropriate for the individual's of diverse backgrounds, whether it's ethnic group, gender, education level, etc. Again, it's all about fairness, and you should have an understanding of the culture of priority populations, who is a part of the population, who's a part of your survey population, and who's a part of your actual sample. And a lot of this has to do with cultural competency or cultural intelligence, and that's something that is really important for health professionals so that you can work effectively across diverse groups. So always consider whether the measurement that you are using is appropriate and is fair for those who you are measuring. Okay, now we're to the end of the slides. And again, this is just kind of like a summary, even though it was a little long. Actually, a lot long. Writing lab. So kind of go through the other chapters, the other slides. But for this writing lab, I want you to really think, now that everyone pretty much has a topic, write down 2 to 3 research questions, mostly for a thesis, or objectives or specific aims if you have a capstone. I want you to name and be really specific about what is your independent variable and what is your dependent variable, but also define each. So instead of saying, my independent variable is stress, tell me which scale you think you might use. So my independent variable is stress, and I'm using the such and such, the Cohen's stress scale, for example. My dependent variable is weight status, and I'm going to be using BMI defined as XYZ. Or I'm going to be using my dependent variable is, instead of saying healthy eating, again, being more specific, caloric intake, and I'm defining that by XYZ. Or my dependent variable is fruit intake, and I'm defining that by the CDC standard guidelines, which is da, 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 da. So not only naming your independent variable, your dependent variable, and there could be multiples of each, but really understanding how you are defining each. And also think about where are you getting the data from? Are you collecting it yourself? Is there a database that is already done and ready to go that you can analyze? Really think about where you're getting this data. Sometimes students get caught up in wanting a very specific research question, but there is either 1, no time to collect it yourself, or 2, there's no data. And so then you kind of get in this conundrum of, well, you're stuck trying to figure out what to do for your thesis or capstone. So really just make sure, how are you getting the data? And or if you think you have the time and an capability to collect the data yourself. So just kind of let me know about that. If you can kind of work on these even better with your chair of your committee, even if it's just a working draft, send that to me, not by this Sunday, but next Sunday. This Sunday, even better if you can meet with your chair. I really want to push everybody along, but I know that for some faculty, they might not be able to meet with you until next week, so that's why I'm just extending it to not this Sunday, but the next Sunday, September 8th. But again, try to have a meeting with your chair and talk through, have a good sketch of these so you're not coming empty-handed. Have a good sketch of your research questions, how you're defining it, where is this data coming from. Meet with your chair, and then send me a draft of that by Sunday the 8th. Also a reminder that since you're meeting with your chair, have them, hopefully someone has said yes, have them sign your thesis capstone approval form, which is the first section only. If you remember, the second section is after you do your proposal defense. And then as soon as possible, talk to your chair about a second committee member, invite them to join your thesis or capstone committee, and then also ask them to sign. Once you have your chair signed and your second member signed, please let me know who they are, because then basically you have your thesis or capstone committee formed, and I want to make sure I know who's on everybody's committee. So that's your writing lab assignment, and you could submit that through Cougar Course. Okay, so just kind of backtracking a little bit with, are you using a research question, objective, or specific aim? Which do you use? Again, work with your chair. Some people have preferences, and depending on what you're doing, a thesis or a capstone. Again, what's your independent variable? What's your dependent variable? Is there a scale that already exists that can help you define those variables? And where are you getting your data? Here's an example with a short a short justification, and an example of specific aims. And the abstract is identifying adolescents who are at increased risk for a particularly difficult pregnancy and adjustment into parenthood is important, as the physical and psychological development of their infants rest in the well-being of these new mothers. So therefore, this study aims to examine the effects of prenatal stress and parenting stress and its association with 1. Adolescent maternal adjustment, and 2. Postpartum emotional distress. So actually, this is my MPH thesis that I did, and what I was able to do is categorize adolescent parents or pregnant adolescents into 4 categories, because they either experienced prenatal stress only, parenting stress only, so after they gave birth, or maybe they experienced no stress, or maybe they experienced both prenatal stress and parenting stress. So based on those 4 groups of people, I then looked at, well, how did that relate to adolescent maternal adjustment? And then second, how did that relate to postpartum emotional distress? And all of these 2, maternal adjustment and emotional distress, had specific scales tied to them. And then I categorized prenatal and parenting stress also with specific scales. So this is an example of the way to word it with specific aims. And I'll show you another example with these same questions worded as more like research questions. But here's my example from my MPH. Many moons ago. Okay, how to write a good research question. Sometimes people will say, like, how do I write a research question? Well, a good research question is a well-researched one. And that means you kind of have to dig into the literature a little bit to understand what questions are there to be asked. You don't know what you need to know until you understand what you don't know, if that makes sense. Get into the literature. You have a topic of interest, start Googling, start looking at some peer-reviewed manuscripts. Then you'll start to get an idea and maybe perhaps be able to identify gaps in knowledge. Is there a need for confirmation or further analysis? Basically, you want to make sure that it passes the so what test. Again, a good research question is one that is that you have researched and have been able to identify as something that is maybe needed. It's a gap in knowledge, and of course, so what? Why does this matter? You also want to make sure that the research question is specific. So what are the independent and dependent variables? When, for whom? If it's exploratory or qualitative, it might be a bit broader. You still want to be as specific as possible. But for example, if it's something new, you might ask something as far as a research question is, what factors influence X, Y, Z? So again, it's kind of more exploratory, maybe tied to more qualitative work. And then you have more known topics, or when there's data available, again, you want to be as specific as possible. For example, the way that I wrote my MPH thesis was more specific aims, but if I were to word it in one question, there's probably 4 questions there. But one of the questions could have been, what is the relationship between prenatal stress and adolescent maternal adjustment? That's very specific. I know what my independent variable is. I know what my dependent variable is. To make it even more specific, I might say among adolescent mothers, or something just to be even more specific, and who, and maybe even when, and like when were they surveyed or in what context. So being as specific as possible is important for a good research question. And then just make sure it's something you can actually answer. Of course, you can have a brilliant research question, but if it's something that you can't answer, or at least within this program can't answer in a timely manner, then it's not a good research question. So you want to make sure that it's something that you've researched well into. It's very specific. You don't want to get too specific, because then again, it leads to number 3. Sometimes you can't answer. So you want to make sure that it's, you researched well, it's specific, but it's also something that you can answer, and that is especially reasonable for your thesis or capstone. Lastly, again, I didn't want to reinvent the wheel, but these are 3 videos that I kind of want to say are required to watch, because the first part is really just about getting started in the thought process. The examples in here, not so much related to us, but I like the way that they introduce just getting started in thinking about research questions. How do you start to Google things or look in journals? And then how do you, is kind of like that first point. A good research question is a well-researched one. How do you start to formulate a question? Well, it's by, looking more into it and then starting to ask questions yourself. So that first video is more about getting started, kind of the thought process of starting to develop your research question. Now, the next 2, I want, whether you're doing quantitative or qualitative, I would want you to watch both videos, because each have characteristics of how you develop a research question. That is really important. So please watch both videos no matter what. So the first one again is quantitative research questions, and what do those look like? And the last one is actually from my alma mater, from Yale University. And it's someone giving a talk on qualitative research questions. And again, this one is a really nice video just on how to think about research questions in general, how specific you should be, and basically how purposeful you should be in developing your research questions. So again, even though I can't track, I do want to say that watching these videos is required, because it will be very, very useful for you in creating your research questions for the writing lab of this week. And I think that's it. And this was a long lecture, but again, it's another important one. And please always let me know if you have any questions.